Okay, so this is the last problem of the yesterday's lecture. In that we have some calculation we have done, but remaining part we have to remaining part of that problem solve we have to today. Okay, so a wall 300 thick is made up of two layers A and B. The temperature is shown in this sketch. The ratio of thermal conductivity of two layers is given Ka by Kb is equal to 2. Ka by Kb is equal to 2. So in this case, they have given the two layers, that is layer A and layer B. So what is to be given? T1 is given, means the temperature at the left hand side of the layer A is given, that is 1325 degrees Celsius. Then temperature at the right hand side of the layer A, that is 1200 degrees Celsius. And similarly for the layer B, left hand side temperature is same, that is 1200 degrees Celsius, and right hand side temperature is 25 degrees Celsius. So from this given data, our aim is to calculate the ratio of the thickness of the two layers. Means we have to find out the LA by LB, and then we have to find out the what is the thickness of the layer A. So our aim is to calculate the LA by LB and only LA. So basically in this case we have to write down the Fourier's law of heat conduction for the two sections. Means for the section A or layer A we have to write down the Fourier's law of heat conduction. Then similarly we have to write down the Fourier's law of heat conduction for the layer B. But whatever the heat transfer takes place through that layer A, that same amount of heat transferred will be takes place through the section B or layer B. So we have to equate the equations for the layer A and B. So from that equation we get the value of LA by LB, that is nothing but 0.213. Okay. Okay. So what is the equation for the layer A? That is heat transfer through layer A. What is the unit? What is the notation for that? QA, because heat transferring through that particular layer. So what is the equation for that? QA is equal to K into A into dt by dx. So K is nothing but thermal conductivity of that layer. So K is there into area, surface area through which the heat transfer takes place. Then temperature difference for the layer A, that is T1 minus T2 divided by thickness of that particular layer, that is L of thickness of that layer A. Similarly, we have to write the equation for the layer B, that is heat transfer rate through that particular layer. QB is equal to KB into thermal conductivity of that layer B into area into what is the temperature difference for that particular layer B, that is T2 minus T3 divided by thickness of that particular layer, that is LB. So whatever the heat transfer takes place through layer A, that much is equal to whatever the heat transfer through the layer B. So we have to equate the equation of QA and QB. So from that we get the equation that is K into T1 minus T2 divided by LA is equal to KB into T2 minus T3 divided by LB. So area is same because heat transfer is takes place for the layer A and layer B having surface area is same, that is the normal to the direction of heat flow. So that area for the layer A and layer B is same. So therefore area will be cancelled, and what is the remaining equation, that is K into T1 minus T2 divided by LA is equal to KB into T2 minus T3 divided by LB. So from that we know the values of the T2 is T1 is given, T2 is given, T3 is given. So put that values into the equation. Similarly, the ratio of thermal conductivity is given, that is Ka by Kb is equal to 2. So put that values into the equation, and then we get the value of La by Lb. Means our aim is to calculate the ratio of thickness of two layers, means we have to calculate the La by Lb. So from that equation we get the value of La by Lb is equal to 0.213. Okay, so this is about the first answer, that is ratio of thickness of two layers. In the second case we have to find out the thickness of layer A, means we have to find out the value of La. So from this equation, that is La by Lb is equal to 0.213. so from that equation what is the value of LB? So LB is equal to LA by 0.213. So 1 upon 0.213 is nothing but 4.7. So LB is equal to what? So from this equation, LA by LB is equal to 0.213. We get the value of LB is equal to 4.7 into LA. And the total thickness of the layer A and B, that is given. So that value is equal to 300 mm. So 300 mm is converted into meter. So that is 0.3 meter. So thickness of both layers is given, that is 0.3 meter. So LA plus LB is given. So LA plus LB is equal to 0.3 meter. And what is the value of LB? LB is in the form of LA, that is 4.7 into LA. So put that value of LB into the equation. So LB is equal to 4.7 LA. So instead of LB, you have to put the value of 4.7 into LA. So what is the equation? LA plus 4.7 LA is equal to 0.3. Okay. So 1 plus 4.7, that is nothing but 5.7 LA is equal to 0.3. So from that we get the value of LA. So LA is equal to 0.0526 meter. Okay. So from that we get the value of LA in mm, that is 52.6 mm. So what is the thickness of the layer A? That is 52.6 mm. 52.6 mm. Okay. So this is about the problem which is related to the Fourier's law of heat conduction. In this case, we have considered as a composite wall, means two walls connected to each other, and for that we have calculated the ratio of the thickness of two layers, and then we have calculated the thickness of the layer A. Okay, so this is about the, I think this is third problem. Write down the next problem. Okay, so write down this problem. Last problem on the Fourier's law of heat conduction. Write down a concrete wall, a concrete wall, a concrete wall which has a surface area, a concrete wall, a concrete wall which has a surface area of 30 meter square, a concrete wall which has a surface area of 30 meter square, 30 meter square, and 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 is 0.4 meter thick, and is 0.4 meter thick, comma, separate the conditioned room air, separate the conditioned room air from ambient air, separate the conditioned room air from ambient air, from ambient air, from ambient air, full stop. The temperature of the inner surface, the temperature of the inner surface, temperature of the inner surface of the wall, the temperature of the inner surface, temperature of the inner surface of the wall is maintained at 25 degrees Celsius, 25 degrees Celsius, and thermal conductivity of concrete is, and thermal conductivity of concrete is, thermal conductivity of concrete is 1 watt per meter Kelvin. Thermal conductivity of concrete is 1 watt per meter Kelvin, 1 watt per meter Kelvin, full stop, full stop. Determine the heat loss through, determine the heat loss through wall, heat loss through wall for outer surface, heat loss through wall for outer surface temperature of, heat loss through wall for outer surface temperature of minus 15 degrees Celsius, minus 15 degree Celsius minus 15 degree Celsius. Okay, solve this problem by your own. Write down first given, write down the problem, write down the given values, and then we have to use the equation and find out the value of Q. Our aim is to calculate the heat loss, means we have to calculate the Q. So first of all, we have to read the problem carefully and write down the given values, and by using that given values, we have to use the Fourier's law of heat conduction, and by using that equation, we have to find out the value of Q. Okay. So solve this problem and put that answer in the chat box. It is simple problem. Only here the values of the outer surface temperature is given in the negative. That is T2 is equal to minus 15 degrees Celsius. Okay. So use this value and find out the value of Q. Put that answer in the chat box. Anyone got the answer? Anyone? Don't sit idle. Do the calculation, write down the given condition, and solve that problem by using the calculator and put that answer in the chat box. This is the very simple problem on the Fourier's law of heat conduction. By this, we have to understood the basic concepts or basic idea related to the heat transfer subject, so that we have easily entered in the actual toughest problem in the heat transfer. After this, there is a next concept which is related to the convection, and then we have to go for the general heat conduction equation in Cartesian coordinate system. So for going into that part of the syllabus, first of all you have to understood the basic concepts. Okay. Dhanashri, Sonone, Arti, Yasar have put their answer in the chat box. What about others? Only half minute is required to solve this type of problem. Still there are some students, they are not solving the problem, only sitting in the ideal. Okay. This is the very important subject as concerned to the mechanical engineering, because heat transfer having many applications. You have to consider any exam, GATE exam, this subject having 7 to 8 mark weightage. Okay. Suppose we are doing MTech in thermal, then there is a need of heat transfer subject. We have to understood the basic concepts of the heat transfer. What is meant by heat? What is meant by conduction, convection, radiation? What is meant by Fourier's law of heat conduction? So these all concepts related to the heat transfer subject. So we have to understood. Okay, what about others? Only 5 students are put their answer in the chat box. What about the remaining? Okay, it is very simple problem. We know that what is the Fourier's law of heat conduction, that is Q is equal to K into A into dt by dx. Okay. So first of all, you have to write down the given conditions. What is to be given? Concrete wall which has a surface area is given. Surface area is nothing but capital A is equal to 30 meter square. Thickness is given, means L is given. L or dx is given, that is 0.4 meter. Then wall temperature is given, that is 25 degrees Celsius, that is T1 is equal to 25 degrees Celsius. Then thermal conductivity is given 1 watt per meter Kelvin, and outer surface temperature is given minus 15 degrees Celsius, that is T2 is equal to minus 15 degrees Celsius. So our aim is to find out the heat loss. So Q is equal to K into A into T1 minus T2 divided by L. So by using that equation we have to find out the value of Q. Value of the Q. Okay. So how to find out the value of Q? Q is equal to K into T1 minus T2 divided by L. So K is given 1, area is given 30, temperature reference is T1 minus T2. So T1 is equal to 25, minus minus becomes plus. So T2 is equal to 15. So 25 plus 15 divided by thickness is given 0.4. So by using that we get the value of Q, that is 3000 watt. Okay. Write down those who are remaining, write down this formula and write down this answer. Q is equal to K into dt by L. Put that values into this equation, find out the value of Q. Okay. So this is the simple problems related to the Fourier's law of heat conduction. Fourier's law of heat conduction. So this is the basic concept. So for the solving of the conduction problems, there is a need of to find out the values of Q, values of area, then we have to find out the thermal resistance. So for that there is a need of Fourier's law of heat conduction, so that we have solved the some problems which is related to the Fourier's law. Okay. Then write down the next point, law of convection. Okay. Write down. Next concept we have to write down the law of convection. Write down. Okay. Reply me. All of you written this problem. Q is equal to 3000 watt. Okay. So this is the simple problem. Now write down the next concept, law of convection. Law of convection. Write down. Next point, law of convection. In that, write down which is the law related to the convection, that is Newton's law of cooling. Which is the law of convection, that is Newton's law of cooling. So write down Newton's law of cooling. Of cooling. Newton's law of cooling. There is a one separate unit is there, convection. But for the conduction, for the solving the sum of the problems in the conduction, there is a need to understand the concept of the convection. So for that we have considering the law of convection in that Newton's law of cooling. So write down Newton's law of the cooling. So before going to this Newton's law of cooling, basically what is meant by convection? Convection is nothing but transfer of heat because of the motion of the fluid molecules such as air or water. Means suppose we have to heating the water in any pot, then what will happen? Whatever the molecules which is at the bottom side, they gaining the energy, and that molecules will changing their position from one location to the another location. So because of this motion of the molecules in the conduction, the molecules are not changing their position, but in the convection, molecules transferring their energy because of the motion of their itself. So in convection, heat transfer takes place due to the motion of molecules, but in the conduction, molecules are stationary. Heat transfer takes place because of the physical contact, but in the convection, molecules are gaining energy and changing their position from one location to the another location, and in this way there is a formation of current is takes place inside that particular fluid. Okay. convection is possible in the liquid and gases. Convection is not possible in the solid because the particles within the solid are tightly packed up. So there is a no possible of convection in the solid. Convection is possible in the liquid and gases. So whatever the molecules which are present in the liquid, that molecules gaining the energy and they are changing their position from one location to another location, and in this way current is formed, and due to this motion heat transfer is takes place. That is nothing but convection. That is nothing but convection. So in that we have to see one law, that is Newton's law of cooling. Newton's law of cooling. Okay. So consider one hot plate. So consider this is a hot plate, and having the hot plate having surface temperature is Ts. Having surface temperature is Ts, and on this surface fluid flow is taking place. Fluid is having temperature. We have to consider that temperature is a TA, that is ambient temperature or fluid temperature. What is the notation for that? TA or TF. What is the notation for that? TA and TF. So this surface is having temperature is Ts. So because of this hot plate, heat transfer is takes place from the higher temperature region to the lower temperature region. So whatever the fluid flow takes place through that particular surface, what will happen? The heat transfer is takes place from the surface to that particular fluid, because what we have considering the Ts is greater than Ta. Ts is greater than Ta. So in this way, the heat transfer is takes place because of the motion of the molecules. Whatever the molecules which are coming nearer to that particular surface, they gaining the energy, and because of that what will happen? The density of that particular molecules will be reduced. Then that molecules will move in the forward direction. Then again some molecules come at the surface and gaining the energy. So that molecule gaining the energy and changing their location from the one point to the another point. So in this way heat transfer is takes place. That is nothing but convection. That is nothing but convection. So we have considering the one plate having surface temperature is Ts, and on that surface fluid flow is takes place having temperature we have considered as a ambient temperature, that is nothing but Ta. So because of that heat transfer takes place from the high temperature to low temperature. So Ts is greater than Ta. So heat transfer takes place. The direction of the heat transfer is given, that is Q. Q is nothing but direction of the heat flow. So what is the Newton's law of the cooling? The rate of heat transfer per unit area. Now we have to consider the rate of heat transfer per unit area. In the Fourier's law of heat conduction, we have discussed about the rate of heat transfer, means we have considering only Q. But in this Newton's law of cooling, we have to consider the rate of heat transfer per unit area. So that is nothing but capital Q by A. Rate of heat transfer is nothing but capital Q. But rate of heat transfer per unit area, that is nothing but Q by A. That rate of heat transfer per unit area is proportional to what? Proportional to the difference in the temperature between body and its surrounding. Body and its surrounding. Means here the plate is given. Plate is having temperature, that is Ts, that is nothing but body, and at the surrounding of this particular body there is a fluid flow is takes place. That fluid is nothing but we have to consider air also, their fluid also. So this rate of heat transfer per unit area is proportional to what? Is proportional to the difference in the temperature between body and its surrounding. So in this case temperature of body is Ts and temperature of surrounding is nothing but whatever the fluid flowing at the surrounding of this plate, that is nothing but Ta. So Ts minus Ta. So whatever the heat transfer rate per unit area, that heat transfer rate is directly proportional to what? Temperature difference. Means in this condition what is the temperature difference? Ta minus Ta. Okay. So Q by A, rate of heat transfer is nothing but Q. Per unit area is nothing but Q by A. So that Q by A is directly proportional to the difference in the temperature. Which temperature difference? Between body and its surrounding. So we have to consider that temperature difference is nothing but delta T. So that delta T is nothing but temperature difference between body and its surrounding. So body temperature is Ts and surrounding temperature. So whatever the fluid, whatever the air which is at the surrounding of that particular plate having temperature we have considered as a Ta. So that Ts minus Ta. So Q by A is directly proportional to Ts minus Ta. So our aim is to remove this proportionality sign. So for that we have to consider as a proportionality constant. So in this case heat transfer is takes place because of the convection. So we have to take the constant which is related to the convection. So Q by A is equal to what? H into Ts minus Ta. Q by A is equal to H into Ts minus Ta. So that H is nothing but convective heat transfer coefficient. What is the value of H? H is nothing but convective heat transfer coefficient. In the Fourier's law of heat conduction, for removing the proportionality sign, we have considered as a proportionality constant as a thermal conductivity, and that K is nothing but thermal conductivity, and which is present in the where the conduction is possible. For that material we have to consider it as a thermal conductivity, but for the convection we have to consider the proportionality constant, that is nothing but heat transfer coefficient for the convection. So for that we have to remove the proportionality sign, and instead of proportionality sign we have to write the heat transfer coefficient for the convection. So from that we get the equation Q by A is equal to H into Ts minus Ta. So from that we get the equation of rate of heat transfer, that is Q is equal to H into A into Ts minus Ta. Ts minus Ta. So this is the equation of the Newton's law of the cooling. What is the equation for the Fourier's law of conduction? That is Q is equal to K into A into dt by dx. And what is the equation for the convection? That is Newton's law of cooling. That is Q is equal to H into A into Ts minus Ta. Okay. So write down, first of all draw this diagram. Okay, draw this. This is a surface plate and having temperature is Ts. Only heat transfer is takes place in the upward direction, because at the downward direction we have given the dotted line, that is nothing but there is a insulation. So only heat transfer is takes place in the upward direction, having surface temperature is Ts, and on that surface fluid flowing or air flowing is takes place, and due to that heat transfer between that molecules is takes place, that is nothing but convection, because that air molecules or fluid molecules gaining the energy from that surface and moving in the forward direction. So in this way the molecules gaining energy and changing their location from one position to the another position. So in this way heat transfer is takes place due to the motion of the molecules, that is nothing but convection. So all of you write down this diagram first. Draw this diagram. Surface plate having temperature Ts, heat transfer rate is Q, fluid flow having temperature is Ta, then Ts is greater than Ta. Okay. Then write down the Newton's law of the cooling. What is the statement of the Newton's law of the cooling? The rate of heat transfer. Write down the rate of heat transfer. The rate of heat transfer per unit area. Rate of heat transfer per unit area. We have to considering the पर युनिट एरिया, म्हणजे जी काही हीट ट्रान्सफर होणार आहे ती पर युनिट एरिया किती हीट ट्रान्सफर होणार आहे ती कशी कॅल्क्युलेट करणार आहे आपण, कशाला डायरेक्टली प्रोपोर्शनल असणार आहे तर तुमच्या टेम्परेचर डिफरन्सला डायरेक्टली प्रोपोर्शनल असणार आहे. ओके. सो राइट डाउन द रेट ऑफ हीट ट्रान्सफर पर युनिट एरिया. द रेट ऑफ हीट ट्रान्सफर पर युनिट एरिया is proportional to the difference in the temperature between body and its surrounding. Temperature between body and its surrounding. So from that write down this statement in the form of equation. Rate of heat transfer per unit area. So Q by A is directly proportional to temperature difference, that is delta T. So write down Q by A is directly proportional to delta T. So that delta T is nothing but body temperature minus surrounding temperature. So Ts minus Ta. So Q by A is directly proportional to Ts minus Ta. Then remove that proportionality sign, so that we have considered as a proportionality constant which is related to convection, that is H. H is nothing but heat transfer coefficient for the convection. So Q by A is equal to H into bracket Ts minus Ta. H into bracket Ts minus Ta. Okay. So take this area in the right hand side, so that we get the equation of rate of heat transfer, that is Q is equal to what? Q is equal to H into A into bracket Ts minus Ta. H into A into bracket Ts minus Ta. Okay. Write down the meaning of the each notation. Write down Q is equal to rate of convective heat transfer. In this case, what is the value? Q is nothing but rate of heat transfer, but which heat transfer takes place due to the convection. So it is known as a rate of convective heat transfer. Okay, write down. What is the meaning of Q? Q is equal to rate of convective heat transfer. Okay. Then A is equal to area exposed to heat transfer. म्हणजे जी काय आपण प्लेट कन्सिडर केली आहे त्या प्लेटच्या कॉन्टॅक्ट मध्ये जी काही एअर येणार आहे that surface area is nothing but area exposed to heat transfer. So write down A is equal to area exposed to heat transfer. Okay, we have to understood the concept of area. Area means what? The area on which the molecules of air or molecules of fluid which are in contact with that particular surface. That surface is nothing but surface area is nothing but capital A. That is area exposed to heat transfer. Okay, then Ts is nothing but surface temperature or body temperature. Ts is nothing but surface temperature. Then Ta is nothing but that fluid temperature or surrounding temperature. आता ह्या केस मध्ये आपण काय केलेलं प्लेट कन्सिडर केली आहे त्याच्यावरून आपण फ्लुइड फ्लो होते असं कन्सिडर केलेलं आहे. पण समजा काही केस मध्ये काय असणार आहे एखादा ऑब्जेक्ट असणार आहे आणि त्याच्या सराउंडिंगला एअर असणार आहे. बरोबर, म्हणजे ते एअर म्हणजे काय असणार आहे दॅट इज नथिंग बट सराउंडिंग टेम्परेचर. ओके, सो टी इज नथिंग बट fluid temperature or surrounding temperature. Then H is equal to coefficient of convective heat transfer. Okay, H is equal to coefficient of convective heat transfer. Write down H is equal to coefficient of convective heat transfer. Convective heat transfer. So can anyone tell me what is the unit of H? What is the unit of H? Put that answer in the chat box immediately. What is the unit of H? We know that what is the unit of K, that is thermal conductivity watt per meter degree Celsius. Then anyone tell me what is the unit of H? Immediately put that answer in the chat box. What is the unit of H? That is heat transfer coefficient related to the convection. Anyone or anyone unmute yourself and put that tell me the answer of that unit of H. Or they have put an answer watt per meter square Kelvin. Okay, so what is the answer? Watt per meter square Kelvin. हे लक्षात ठेवायचं आहे. थर्मल कंडक्टिव्हिटी, what is the unit of thermal conductivity? Watt per meter Kelvin. And what is the unit of thermal heat transfer coefficient for the convection? That is watt per meter square Kelvin. What is the difference? In the thermal conductivity meter is there and in the heat transfer coefficient meter square is there. Okay, so write down the unit of, okay, what is the unit of H? Write down the unit of H is equal to Q by, how to write that equation? Rearrange the term. H is equal to what? Q divided by A into Ts minus Ta. So what is the unit of rate of heat transfer? That is watt. What is the unit of area? That is meter square. And what is the unit of temperature difference? That is in Kelvin or in degree Celsius. Kelvin or degree Celsius. Okay, so from that, what is the convective heat transfer coefficient? So H is equal to Q. असं आपण कधी म्हणू शकतोय? When the unit area is there, when the temperature difference also unit, then we said that heat transfer coefficient for the convection is nothing but amount of heat transfer through that particular object. So what is meant by convective heat transfer coefficient? The convective heat transfer coefficient is defined as the amount of heat transmitted for a unit temperature difference between the fluid and unit area of surface in unit time. Okay, so from this equation we have written the equation H is equal to Q upon A into Ts minus Ta. So H is equal to Q when area is equal to 1 and Ts minus Ta is equal to 1. At that time what we said, convective transfer coefficient is nothing but amount of heat transmitted for a unit temperature difference between the fluid and unit area of surface in unit time. So write down the definition of the convective transfer coefficient. Write down the convective heat transfer coefficient is defined as the convective heat transfer coefficient is defined as the amount of heat transmitted. The convective heat transfer coefficient is defined as the amount of heat transmitted for a unit temperature difference for a unit temperature difference between the fluid and unit temperature difference between the fluid and unit area of surface and unit area of surface in unit time in unit time in unit time. So this is the definition of the convective heat transfer coefficient. Convective heat transfer coefficient म्हणजे काय असणार आहे, अमाऊंट ऑफ हीट ट्रान्समिटेड, कधी ज्यावेळेला टेम्परेचर डिफरन्स युनिट असणार आहे, ज्यावेळेला त्या सरफेस जो असणार आहे त्याचा एरिया युनिट असणार आहे आणि युनिट टाइम मध्ये आपण त्यावेळेला मेजर करणार आहे ती जी काही हीट ट्रान्सफर असणार आहे दॅट इज नथिंग बट कन्वेक्टिव्ह हीट ट्रान्सफर कोएफिशिएंट. ओके, देन राइट डाउन द व्हॅल्यू ऑफ H. The value of H depends on the following factors. The value of H, that is convective heat transfer coefficient, depends on the following factors. जो काही हीट ट्रान्सफर कोएफिशिएंट असणार आहे कन्व्हेक्शन साठीचा तो कशावरती डिपेंड्स असणार आहे. सो द व्हॅल्यू ऑफ H डिपेंड्स ऑन दी फॉलोइंग फॅक्टर्स. राइट डाउन फर्स्ट फॅक्टर. The value of H depends on the following factors. First one, thermodynamic and transport properties. Thermodynamic and transport properties. Thermodynamic and transport properties means in this case we have considered one plate and on that plate we have considered as a fluid is flowing. So what is the convective heat transfer coefficient for this particular condition? This is depends upon the thermodynamic and transport properties. What are these properties? The transport property is nothing but viscosity is there. Thermodynamic property is nothing but specific heat is there. So on this, what is the viscosity of that particular fluid? What is the density of that particular fluid? What is the specific heat? So on these factors, the value of H is depend. So write down in bracket viscosity, comma density, comma specific heat, etc. Okay, viscosity, density, specific heat, etc. These are the thermodynamic and transport properties. On this means suppose one plate fluid is flowing on that particular plate, suppose having density is higher, at that time heat transfer coefficient is different. If density is low, at that time heat transfer coefficient is different. So according to that value of H is depends. Then second, write down nature of fluid flow. What is the nature of fluid flow? There are different types of fluid flow is there, that is laminar is there, turbulent is there. So for that case the heat transfer coefficient value is different. So write down nature of fluid flow, nature of fluid flow. Then third is geometry of the surface. So whatever the surface we are considering, on that surface fluid is flowing. So what is the geometry of that surface? It may be there are different shapes are possible. So due to that shape, what will happen? The heat transfer coefficient will be different. So according to the shape, the heat transfer coefficient is depends. So write down geometry of the surface, geometry of the surface. Okay, geometry of the surface. So this is the three factors on which heat transfer coefficient is depends. Then write down the equation. What is our equation of the Newton's law of heat? Newton's law or Newton's law of cooling, that is Q is equal to H into A into bracket Ts minus Ta. Write down Q is equal to H into A into bracket Ts minus Ta. Q is equal to H into A into bracket Ts minus Ta. Okay. Now we have to write down this equation in the form of electrical analogy. Means what? Heat transfer is takes place because of the temperature difference. Means Q is transferring because of the temperature difference is nothing but Ts minus Ta. Means in the electrical system we have written the I is equal to dV by R. So in that manner we have to write down this equation. So how to write this equation in the form of electrical analogy, that is Q is equal to Ts minus Ta divided by remaining factor. So in this case Ha is remaining factor. So we have to take that factor in the denominator. So it is at the numerator. When we have taking at the denominator, then this factor will going at the denominator of the denominator. So how to write this equation, that is Q is equal to Ts minus Ta divided by 1 upon Ha. So these two equations are same, only we have changing the positions of the values, that is HA at the numerator we have taken as a denominator of the denominator. Okay, so from this equation we have to compare this equation with the electrical system equation. So from that we get the value of thermal resistance. So in this case heat is transferring because of this temperature difference, means Q is flowing because of the Ts minus Ta. But which factor opposes the heat transfer? That is 1 upon Ha. That 1 upon Ha is nothing but resistance for that particular heat flow. 1 upon Ha is resisting the heat flow. So this is the resistance for the heat flow, 1 upon Ha. But this resistance is because of the convection. So what is the name for this 1 upon Ha is nothing but thermal resistance for the convection. ओके, सेम आपण कंडक्शन साठी पण इक्वेशन फाइंड आउट केलं तर कंडक्शन मध्ये काय आलं dx by k. So that factor opposes the heat transfer in the conduction, and 1 upon Ha, this factor opposes the heat in convection. So we have to write down the equation Q is equal to Ts minus Ta divided by 1 upon Ha. So this 1 upon Ha is nothing but thermal resistance for the convection. So write down Q is equal to Ts minus Ta divided by thermal resistance of convection. Thermal resistance of convection. Thermal resistance of convection. Thermal resistance of convection. Okay. So thermal resistance of convection is equal to what? 1 upon Ha. So this denominator factor is nothing but resistance. That is nothing but 1 upon Ha. म्हणजेच काय असणार आहे? Convection thermal resistance. So write down thermal convection resistance is equal to 1 upon Ha. So many times they are asking the calculate the value of thermal resistance for convection. At that time we have to use this equation 1 upon Ha. By using that we have to find out the value of thermal resistance for the convection, that is 1 upon H into A. Okay, 1 upon H into A. Okay, so this is the Newton's law of the cooling. Okay, first we have discussed about the Fourier's law, and that law which is related to the conduction. And now we have discussed the law, Newton's law of the cooling, and this law related to the convection. दोन्हीची इक्वेशन लक्षात ठेवायचं आहे. What is the equation of the Fourier's law of heat conduction? Q is equal to K into A into dt by dx. Okay, and what is the Newton's law of the cooling? That is Q is equal to H into A into bracket Ts minus Ta. So these two are different equations. First equation we have to use for the conduction, and Q is equal to H into A into Ts minus Ta. This equation we have to use for the convection. For the convection. And what is the thermal resistance for the conduction? That is dx by k. By using that we have to find out the value of thermal resistance for the conduction. And for the convection, 1 upon Ha is nothing but thermal resistance. That 1 upon Ha is nothing but thermal resistance for the convection. And by using that we have to find out the value of thermal resistance for the convection. Thermal resistance for the convection. Okay, so this is the law which is related to the convection, Now we have to solve these simple two problems on the Newton's law of the cooling. Okay, write down the first problem. Okay, write down first problem. A hot plate 1 meter into 1.5 meter. A hot plate 1 meter into 1.5 meter. 1 meter into 1.5 meter is maintained at 300 degrees Celsius. Is maintained at 300 degrees Celsius. 300 degrees Celsius. 300 degrees Celsius. Full stop. Air at 20 degrees Celsius. Air at 20 degrees Celsius. 20 degrees Celsius blows over the plate. Air at 20 degrees Celsius blows over the plate. blows over the plate, blows over the plate, full stop, if the convective heat transfer coefficient is, if the convective heat transfer coefficient is 20 watt per meter square degree Celsius, if the convective heat transfer coefficient is 20 watt per meter square degree Celsius, 20 watt per meter square degree Celsius, calculate the rate of heat transfer, calculate the rate of heat transfer, rate of heat transfer. Okay, so from this value heat transfer coefficient, okay, in so many problems they are not given whether this problem is related to conduction or related to convection. So how to understood whether this is problem related to conduction or related to convection? If in the problem they have given the value of thermal conductivity, then we have to understood this is the problem related to the conduction. And if in the problem they have given the value of heat transfer coefficient, that is watt per meter square degree Celsius, then we have to understood this is a problem which is related to the convection. Okay, so write down first given, and by using that Newton's law of the cooling, Q is equal to H into A into Ts minus Ca, we have to find out the value of Q. Okay, solve kara, solve this problem and put that answer in the chat box. Simple problem. What is the Newton's law of cooling? Q is equal to H into A into Ts minus Ta. Ts म्हणजे काय असणार आहे, त्या बॉडीचं टेम्परेचर असणार आहे, आणि TA म्हणजे काय असणार आहे, सराउंडिंगला जी काय एअर असणार आहे. आता इथं आपण एअर ब्लो करतो, त्याचं टेम्परेचर दिलेलं आहे तुम्हाला 20 डिग्री सेल्सिअस. म्हणजे TS इज गिवन, TA इज गिवन, area is given 1 meter into 1.5 meter. Product of that two is nothing but area. 1 into 1.5 means 1.5 meter square. Okay, and H is given, convective heat transfer coefficient. Convective heat transfer coefficient is 20 watt per meter square degree Celsius. 20 watt per meter square degree Celsius. Hmm. Okay. Yeah, sir, get the answer. 8400 watt. Okay. Abhijit Kote 8.4 kilowatt. Dhanashri 8400 watt. Okay. Only 3-4 students are solving the answer and putting their answer in the chat box. What about others? They are only attending the lectures, or so many students are sleeping. Okay, there is no use of attending the lectures when we are sleeping there. We are not doing the calculation, we are not doing the understood the concept. Then what is the use of attending the lectures? Okay, we have to do the calculation, because we have to giving the simple problems. After that there are so many tough problems are there. First of all, you have to understood the simple problems. You have to change your mind towards the heat transfer, so that we have to easily understood the difficult problems. Okay, so it is very simple problem. Okay, so area is given 1.5 meter square, Ts is 300 degrees Celsius, Ta is equal to 20 degrees Celsius, H is 20 watt per meter square degree Celsius. So what is the Newton's law of cooling? Q is equal to Ha into Ts minus Ta. So H is 20, area is 1.5, Ts is 300, Ta is 20. So from that we get the answer of 8400 watt. 8400 watt. Okay, so this is the first problem. Then write down the second problem. Write down. Okay, first of all of you put your roll numbers in the chat box, so that I have to take your attendance. Okay, so how to solve this problem in the tomorrow's lecture. Now I have to stop here. All of you put your roll numbers in the chat box. Okay, thank you very much.